Welcome back everyone. The next sorting technique which we are going to study now is called as quicksort. Now this quicksort also comes under the header of divide and conquer kind of algorithms as it was with the merge sort. Now the basic idea behind quicksort is also as that of a merge sort, that we are going to divide our array into equal halves and we are going to always keep on sorting those halves until the time we are not reaching with the individual elements and then start merging the same. The idea of quicksort is slightly different as compared to that of merge sort. If we check in a quicksort, we select one element which is called as a pivot element. Now this pivot element can be from any location. It can be from the beginning of the array, it can be at the end of the array, or it can be somewhere in the middle of the array also. In the pivot element, the main idea behind selecting the pivot element is we have to fix the location of the pivot element into the given array. Now, it's not necessary that the elements before the pivot element have to be sorted or the elements after the pivot element have to be sorted. It's not necessary in that way, but we have to fix the location of the pivot element. This is the first crux of quicksort algorithm. Let's check in this given array. So we have an unsorted array in this way, like 9, -3, 5, 2, 6, 8, -6, 1, 3. Okay, we have selected 3 as the pivot element. Now, after doing some kind of algorithm, let's say which is a quicksort algorithm, which we are going to just do in due course of time, we have fixes the location of 3 over here. Now, when I'm fixing the location of 3 over here, what does this mean? This is the correct location of 3. If I just tell you to sort this array, how we are going to sort this array? Let's check it. So, I'll be utilizing this space. So let's say I'll sort this array. So I'll have -6, then I am going to have as -3, then I am going to have 1, then I'm going to have 2, then I'm going to have 3, then I'm going to have 5, 6, 8 and 9. This is going to be my sorted array. Now if I check 3 is at the 5th position. So, after doing quicksort algorithm, I have fixed 3 at its correct position. Now, need not necessary that the elements before 3 are sorted or elements after 3 are sorted. It's not necessary. But one thing is very sure. All the elements which are below 3 or less than 3 will always be on the left hand side of 3. And all the elements which are higher than 3 are always on the right hand side of 3, which can be denoted very clearly from this diagram. Now later on, this half of the array can be sorted using merge sort, which we have already discussed in the previous videos. If you have not seen the video of merge sort, I'll request to see it first before going for quicksort, because that is going to be helpful to you in understanding what is the criteria, what is the technique behind divide and conquer algorithms. So I can divide each of the elements separately and then I can go for merging those things. So the two halves can be sorted using merge sort algorithm or any sorting algorithms whichever we have covered before this quicksort. But fixing of the pivot element is something which quicksort algorithm usually looks for. So let's go ahead. If an array only contains one element, so return, okay, else, because if it's a single element, so it is definitely sorted else. Pick one element to use as pivot. Partition the elements into 2 sub-arrays. I'll just remove the annotations. So you'll pick one element to use as a pivot. Now there is no rule as to which element has to be the pivot. It can be any element from the given array. Then we can partition the elements into 2 sub-arrays. So elements less than or equal to pivot, we are going to always put it on the left side and we are going to find out which are the elements that are greater than the pivot. And later on, you are going to quicksort the 2 sub-arrays. That is again, the same process has to be applied on the next 2 halves. and then we can return the results. Thank you everyone.